Welcome, Algebra 2 students. This is Lesson 4.2, Adding, Subtracting, and Multiplying Polynomials. So the first couple problems are going to be pretty easy because you've actually already done this an awful lot, and you'll think of these problems as combining like terms, and that's all we're really going to do when we're going to add two polynomials together. So let's look at number one. So number one is 2x to the third plus x squared minus 3x plus 4 plus x to the third plus 7x squared minus 2. And we're just going to look for like terms. So remember, like terms have to have the exponent, and we're just going to combine those coefficients. So we have, for this first problem, 2x to the third plus x to the third, and that gives me 3x to the third. We'll keep going down here. Let's see here. Do we have any x squared terms? Let's see, we have positive x squared and positive 7x squared, so we can add those together. That gives us 8x squared. Let's keep going on down the line. Do we have any regular plain old x's? We don't. So in the second part of that problem, we're just going to have minus 3x. There's nothing to combine with that. And finally, last but not least, we have this plus 4 and this minus 2 that we will put together. And when we do that, positive 4 minus 2 gives me positive 2. So my final answer is 3x to the third plus 8x squared minus 3x plus 2. Why don't you pause the video right now and try number 2. Go ahead, pause the video. I'm not going to give you a lot of time, but go ahead, pause the video, take as much time as you need, and then we'll go over it. So then again, thinking about like terms, we have this negative 4y to the third, and there's no y to the thirds in the other expression, so we just keep that, negative 4y to the third. We look here at positive 2y squared and a regular y squared. That gives me 3y squared. And then we have this minus y and this minus 6y, which gives me minus 7y. And finally, we have plus 2 plus 9, which is plus 11. So my final answer, negative 4y to the third plus 3y squared minus 7y plus 11. Subtraction is very similar to addition, with one exception. You have to remember you're subtracting this entire quantity. So what I like to do is I like to rewrite this as an addition problem where I distribute that negative sign through my entire parenthesis to all of those terms. So when I rewrite that by distributing that negative sign, you'll notice the first parenthesis didn't change at all. But the second parenthesis, I'm just going to go through and I'm going to change all of my signs. That just makes life a lot easier for me. And then I'll just combine my like terms like I did in the last problem. So I got negative 2x to the third. See here, plus 5x squared, so that's plus 9x squared. Got the minus x and the plus 3x. That gives me plus 2x. And then I have the plus 8 and the minus 1, which will give me plus 7. So there's my final answer. Again, pause the video and try number 2 on your own. Okay, so we got 7z squared minus 4z. I distribute my negative sign through that second parenthesis. And now I combine my like terms. And I get my final answer of 2z squared minus 3z minus 3. All right. Moving on to multiplication. So when I multiply a polynomial times another polynomial, it's basically like the superdistributive property. So I can take everything in this first parenthesis and I can multiply it by everything in the second parenthesis. So I take this negative x squared and multiply it by both of those terms, then the 2x and multiply it by both those terms, and then the 4 and multiply it by those two terms. I mean, this is essentially what I'm doing when I'm foiling. It's just when I'm foiling, I have that nice acronym so I don't forget anything. When I have a polynomial, I actually have to just remember where I'm at and what I've multiplied already together. So there's me multiplying the negative x squared through by everything. Now let me take that 2x and multiply the 2x through by everything. Okay, I did that. And now finally we'll multiply the 4 by everything in there. Let's see here, that gives me 4x and minus 12. Now you see the nice thing that if you do it right, you can write it in one big long line. It's certainly not wrong. But what's really nice is if you do it this way, things start to line up really nicely and it's easy to come up with the final answer. All right. Why don't you guys pause the video right now and try number 6 on your own? Go ahead, pause the video. I'll be here when you get back. Okay, so the first thing I'm going to do is I'm going to take this 2y and multiply it by everything in the second parenthesis. Now I'm going to take the negative 4y and multiply it everything in that second parenthesis. And finally, I'll take this positive 3 and multiply it by everything in that second parenthesis. Now it's time to add everything together. So that gives me 2y to the third plus 12y squared minus 29y plus 24 is my final answer. But what if I have more than 2 parentheses? What if I have 3 parentheses? Well, not really any different. All I'm going to do is I'm going to take 2 of my parentheses, and you can really take any 2 of your parentheses, and I'm just going to multiply that out. And that should look very familiar to things that we have already done with multiplying 2 binomials together. So I took the first 2 parentheses and I multiplied those together. And now it looks exactly like the rest of the problem. Hey, try to pause the video right now and see if you can finish up this one on your own. See if you get it right. Did you get x to the third minus 2x squared minus 5x plus 6? Because that's what you should have gotten, because that's the right answer. Okay, pause the video right now and try out this problem number 8. Go ahead, pause the video. I'll be here when you get back. So I'm going to go ahead and in this problem, I thought I'd take the second 2 parentheses and multiply those together. So the x plus 3 will stay there, and then when I multiply out the second parentheses, I will get x squared minus x minus 2. And now what I'll do is I'll take this x and multiply it by everything in that second parenthesis. That'll give me x to the third minus x squared minus 2x. And then I'll multiply everything by positive 3. So that's plus 3x squared minus 3x minus 6, giving me a final answer of x to the third plus 2x squared minus 5x minus 6. Now, don't be worried if you didn't do it exactly the way I did. You could have done it the other way by multiplying the first 2 parentheses. Your work is going to look different, but your final answer should be the same as mine. What if I get a problem that looks like this? Well, folks, one of the worst things you can do is distribute exponents. What I just did over here is not correct. Exponents are not distributive, so you cannot take and cube each one of these things individually. It will not give you the right answer. Instead, you need to remember that when you have something written to a power, it's like multiplying it by itself that number of times. So in this case, when I have 2x minus 3 to the third power, that's the same as 2x minus 3 times 2x minus 3 times 2x minus 3. And then it's just like the previous problems we did. We'll take 2 parentheses and we will multiply them by each other. So we'll distribute and combine like terms and we'll end up with 4x squared minus 12x plus 9. And then I can take this first parenthesis and multiply everything in that parenthesis by 2x, and then turn around and do the same thing, multiply everything by negative 3. Looks a little something like this. And then when you add those together, you get 8x to the third minus 36x squared plus 54x minus 27. Again, take a second right now, pause the video, and try number 10 on your own. Remember, that means you're going to multiply it by itself 3 times. So you get 3x plus 2 times 3x plus 2 times 3x plus 2. I'll take the second 2 parentheses and multiply them together. Then I'll take the first parenthesis and multiply everything in the second parenthesis by those 2 terms. And then I will combine everything together and get my final answer of 27x to the third plus 54x squared plus 36x plus 8. So here are some of the different shortcuts and special rules. We've already talked about some of these, like the sum and difference of 2 binomials. We can shortcut that. Here's a good example of what the answer would be. Binomial squared, again, we've seen this shortcut before. Here's 2 examples for you to see. The cube of binomials is new. However, I don't know if remembering this shortcut is necessarily the best thing. It's sometimes easier just to go ahead and multiply everything out than it is to memorize a formula that looks like this, because that just looks really complicated to me. However, when I have exponents that are bigger than 2 or 3, like say even 4 or 5 to a parenthesis, there's actually a really nice pattern that shows up. We can use something called Pascal's triangle. Now, Pascal's triangle, I know it looks really confusing, but I'm going to simplify things for you. I want you to actually look at the triangle that's over here, and I want you to notice how the different numbers are made. Like, for example, if I wanted to create this entry right here, what I would do is I'd take the two diagonal values and I add those together. Like 3 plus 3 gives me 6. If I wanted to get, say, this entry, I'd go with the two diagonals and I'd say 4 plus 1 gives me 5. If I wanted to fill in the next line, right, how would I do that? Well, it always starts with a 1. And then to get to the next entry, I'd do 1 plus 5 and get 6. Then I'd do 5 plus 10 and get 15. I do 10 plus 10 and get 20. I do 10 plus 5 and get 15. I get 5 plus 1 and get 6. And then I know it always ends with a 1. So that would be what my next row would look like in Pascal's triangle. Why don't you take a minute right now, pause the video, see if you can come up with the 7th row of Pascal's triangle. Did you say it was 1, 7, 21, 35, 35, 21, 7, 1? Because if you did, you'd be right. Now, how's this apply? Well, we're going to go and we're going to multiply out this expression, x plus 2 to the 4th power. And I'm going to use it using Pascal's triangle. Now, what I'm going to do is I'm going to go to the 4th row of Pascal's triangle. Let me show you Pascal's triangle on this slide. Basically, what I'm going to do is I'm going to go to the 4th row of Pascal's triangle. And how do I know which one's the 4th row? Well, I look at the second number. The second number here is 4, and that's how I know that this is the 4th row of Pascal's triangle. Now, these give me the coefficients that I'm going to need. So I can go ahead and as I'm expanding this binomial, which is what this is called, binomial expansion, using Pascal's triangle. Sounds really fancy. It's really not. I'm going to see that I have two terms, and I see this exponent of 4. And again, that 4 indicates that I go to the 4th row of Pascal's triangle. For each one of the terms that's in my answer, I'm going to have 3 parts to it. That first part is going to be the coefficients from Pascal's triangle. So I'm just going to write those out, spread them really far apart. The next part has everything to do with what the first term is. And I'm going to write the first term. Please notice I'm putting the first term in parentheses. And I'm going to raise it to the highest exponent, the number that's outside there. So see how that was x plus 2 to the 4th power? I'm going to make that x to the 4th power. And then I'm going to go to each one of my terms, and I'm going to decrease my exponent by 1 every time I write the next term, until I finally get to x to the 0 power. For my last part, I'm going to take this 2, and I'm going to do the same thing. I'm going to write 2 in a parenthesis, but instead of starting at the highest exponent, I'm going to start at the lowest. So I'm going to start at 0, and then for each one of my terms, I'm going to make that exponent increase by 1 as I write it each time. Now, I just have a series of problems that I have to simplify. So I have to multiply this whole thing out. Let's see here. 1, I got x to the 4th. I got 2 to the 0, so that gives 1. So I end up with just x to the 4th for that term when I get there. For my second term, I have 4, I have x to the 3rd, I have a 2. Okay, so that's x to the 3rd. 2 times 4 gives me 8. So I have 8x to the 3rd power. My next one, what do I have? Well, let's see here. 2 squared. 2 squared is 4, so I have 4 times 6, which is 24. And then that x squared. Then I have 2 to the 3rd. 2 to the 3rd, that's 8. 8 times 4 gives me 32. And finally, 2 to the 4th. 2 to the 4th, that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. 16 times 1 gives me 16. X to the 0 is just 1, so that basically goes away. But this actually ends up being my answer. X to the 4th plus 8x to the 3rd plus 24x squared plus 32x plus 16. Now, if you don't want to do it that way, that's not a problem, but the alternative is taking x plus 2 and multiplying it by itself 4 times. Wow, not 3 times, 4 times. That's the alternative. Let's look at one more example problem. 2x minus 5 to the 5th power. So again, I'm going to go to the 5th row of Pascal's triangle. Let me bring that up here for you. So that means I'm going to this row right here. Do you want to take a minute right now? Why don't you pause the video and see if you can write out the expansion of this binomial. Just see if you can get all three of those parts. Remember, the first part has to do with the coefficient. The second part has to do with that first term inside the parentheses raised to the biggest power. And then the second part is the second term raised to the lowest power. See if you can write out that binomial expansion. When you start the video up again, I'm going to have that part written out for you. So go ahead, pause the video right now, see if you can expand that binomial yourself. Wow, okay, how'd you do? How'd you do? Double check yourself. Pause the video right now, make sure you got that written down correctly. This looks really complicated, but trust me, this is a lot easier than multiplying 2x minus 5 times itself 5 times. Promise, this is a lot easier. Now, I am going to do an additional step in this problem that I did not do on the last problem, and it's simply because I have this 2x to the 5th power. I actually want to make sure I multiply that out correctly. I need to remember that the 2 needs to be raised to the 5th power, as well as the x. So the 2 to the 5th power, that's 32. So I have 32x to the 5th power. So that's what I'm going to have that multiplied by. And of course, that negative 5 to the 0 just turns into 1. So that's my first term that I have here. My second term, 5. That's here. 2 to the 4th power. 2 to the 4th power is 16. So that second term turns into 16x to the 4th power. And then I have to turn around and multiply that by negative 5. Okay, what do I got going on next? Let's see here, 10. And I have x to the 3rd. X to the 3rd is equal to 8, so it's times 8x to the 3rd. I got this negative 5 squared. Negative 5 squared is 25, so I'm going to end up multiplying that by 25. I'll keep going. Plus 10. Let's see here. 2x, that quantity squared. Well, 2 squared is 4, so I got 4x squared times negative 5 to the 3rd power. Let's see here. That's a negative 125. My numbers are getting bigger. Let's keep going. Let's see here. Plus 5. Okay, well, now that is easy. I got 2 times x, so that's 2x. Both of those are to the 1st power. And I have negative 5 to the 4th power, which is, that's 625. Okay, when I did the math. And then finally, I have plus 1. I got 2x to the 0 power. That's 1. And then I got to do negative 5 to the 5th power. Thank goodness I have a calculator. That's negative 3,125. And now I can finally write out my final answer, which will be 32x to the 5th when I multiply all that together. So here, 5 times negative 5 times 16 gives me negative 400x to the 4th. I got 10 times 25 times 8, which is plus 2,000x to the 3rd. I got 10 times 4 times negative 125, so that's minus 5,000x squared. 5 times 2 times 625 is plus 6,250x. And then finally, minus 3,125. That is my final answer. Again, trust me, that's a heck of a lot easier than multiplying 2x minus 5 times itself 5 times. Folks, that's all I got for you for this lesson today. So we'll practice this, of course, when I see you again. But please keep in mind any questions that you have. And especially with binomial expansion, make sure you take your time and multiply everything out correctly. See you later.